In this video, we'll be running some examples from the Fotahub Device SDK for Linux. This latter enables developers to create firmware for Linux or Raspberry Pi-based IoT devices that can be updated through Fotahub. The Fotahub Device SDK for Linux and Raspberry Pi can be used on single-board computers like Raspberry Pi and others, Linux-based edged IoT devices, and Linux desktop computers for testing and evaluation purposes. On your laptop, you need the GCC compiler or linker toolchain, the Python 3 interpreter, and a text editor or IDE of your choice, such as Visual Studio Code. The Fotahub Linux SDK comes with 3 examples: Simple, Revertible, and ThinkShadow. We'll run the simple example on a Raspberry Pi and demonstrate a full firmware update cycle using Fotahub. If you don't want to undergo the hassle of connecting keyboard, mouse, monitor, etc. to your Raspberry, you can perform the steps remotely from your desktop computer using SSH. You can achieve that very conveniently by enabling SSH on your Raspberry Pi and installing the remote SSH extension in Visual Studio Code. Guidelines on how to set up and use this feature are provided in the Linux SDK documentation page. If you haven't already done so, start by creating a product on Fotahub. You can check my first introductory video for guidelines on how to do it. In the product creation wizard, enter a name to your product and select the versioning scheme you want to use for your firmware versions. Also choose the binary verification method and algorithm used to verify new firmware versions downloaded from Fotahub before applying them. Finalize the creation of your product. Now you need to connect to your Raspberry via SSH. Start by selecting Remote SSH, add New SSH host from the command palette. You'll then be asked to enter the SSH connection information. Enter the full SSH command you would use to connect to the host from the command line by typing SSH followed by a space, the username, the @ symbol, and the host name. By default, your Raspberry Pi comes with a built-in account Pi and the password Raspberry. The default hostname is Raspberry Pi. Finally, you will be asked to pick a config file to use. This is where the previously entered SSH connection info gets stored so that you won't need to re-enter it when you want to reconnect to a Raspberry Pi in the future. Clone the Fotahub Device SDK for Linux and Raspberry Pi locally from GitHub onto your Raspberry Pi device by providing the clone URL. Now you need to create and run initial firmware version. To do so, open the simple example included in the Fotahub Device SDK for Linux. Open the demo product info header file in the demo product folder and initialize the demo product ID and demo product name constants with the ID and the name of the previously created Fotahub product. In case you have selected anything else than SHA-256 as the binary checksum algorithm for your Fotahub product, or opted for using a signature instead, you also must adjust the demo product firmware update verification algorithm constant accordingly. Open the integrated terminal and build the example by invoking the make command. You can find the resultant firmware program in the bin folder under the build parent directory on your Raspberry Pi. Its name equals the name of the Fotahub product configured in the demo product info header file without spaces. Now you need to create and upload a new firmware version to Fotahub. Go back to the demo product info header file in the demo product folder and bump the demo product firmware version constant. Rebuild the example using make update equals yes this time and locate the resulting new firmware using the Explorer view just as you did earlier. Its name is the name of the Fotahub product configured in the demo product info header file without spaces, followed by an update suffix. Download the new firmware program to your desktop computer. Now you can upload the resulting new program as firmware version 1.1 to your Fotahub product. To do so, go to the Products dashboard and find your product. Click on the product name to open its details view. Click on Upload Firmware and choose the Upload with Wizard option. Enter the version of the firmware to be uploaded and optionally a command. The version format must match the firmware versioning scheme defined upon product creation. Click on Next to get to the binary upload page. Drag and drop or browse the binary of the new firmware version to be uploaded, and then on Upload to start the firmware upload process. When completed, you will be redirected back to the product details view and see the newly uploaded firmware version along with its properties. Most importantly, you will be able to find the firmware binary download URL and its checksum that has been automatically calculated based on the binary checksum algorithm chosen upon product creation. Copy this checksum. Now you can make your first firmware over-the-air update. Go back to Visual Studio Code and launch the initial firmware version via the start script after granting execution permissions to the file. The firmware program prints a banner including the product name and the initial firmware version into the terminal output. It also creates and opens the demo product update.info file directly in Visual Studio Code. Enter the new firmware version followed by a colon, the checksum or signature in the demo product update.info file and save it. This will trigger the firmware over-the-air update procedure. Upon successful completion, the initial firmware program exits and the new firmware version downloaded from Fotahub is started automatically. To verify that, check the firmware version in the banner being printed in the terminal output. Congratulations! You've made your first photo update of your Raspberry Pi using Fotahub.